All right, the final lesson in this chapter, I think, is actually something that a lot of you have already figured out. Right? If we were given a diagram like this, what we usually did before was draw two separate triangles so that we could match up corresponding sides. But if I know, or if I'm given that these two lines are parallel, I can just say that those parallel lines will split up these sides proportionally. So instead of looking at the entire length of one side of a triangle, I can just look at the pieces of the sides and match them up. Okay? For example, if I'm told that Rx is x and xt is 5, and then ty plus ty is 10 and ys is 12, something like that. Okay? What we can say, we can still match up the corresponding pieces on other sides, but we don't have to look at the entire lengths of different pieces. So for something like this, we could just say x over that corresponding piece of 12 is equal to 5 over 10. Okay, so we're still matching up corresponding pieces on the other side. Okay, it's still very similar to what we were doing, but instead of looking at entire side lengths of triangles, as long as we know these lines are parallel, we can just say this piece would match up with this corresponding piece on the other side. And the same here, this piece would match up with this piece. Okay? And then we would solve it the same way. Okay? We would cross multiply. 10x equals 12 times 5 is 60. Divided by 10. And here we would get x equals 6. Like a flash. Right? So we can still match up corresponding pieces. Okay. So in example 1 down here, I've got some expressions, not just single variables. So normally what we did before would make this problem really complicated. And if I drew these two triangles separately and added these two pieces together to get the entire length of AB, I would have 2x plus 24. But what we can do now, since I know these two sides are parallel, I can just match up corresponding pieces of sides. So I can say that AF and AE would be corresponding pieces, and then FB and EC would be corresponding pieces. So I could write x plus 22 over 18 equals x plus 2 over 6. So I'm still matching up corresponding pieces. We just don't have to use the entire side lengths of the triangles now. So this makes the problem a little bit easier. Cross multiply. So 6 times x plus 22 equals 18 times x plus 2. Distribute on both sides here. So 6 times x is 6x. 6 times 22 is 132 equals, I distribute over here, 18x plus 36. Get the x's on one side. So 132 equals 12x plus 36. Subtract the 36 over, plus, get 96 equals 12x. Finally divide by 12, and that is So as long as we know that these two sides are parallel, we can set up a proportion by just matching up corresponding pieces of sides. All right. Questions? All right. So we can also go in the reverse direction of this statement. So we said if these lines are parallel, then I can set up proportions like this. Okay? We can go backwards and say, well, if those proportions are equal, then the line that HK is 5, KG is 10, and then JL is just half the length of LG. Okay, so we're not given actual measurements for JL and LG. I'm just told that JL is 1/2 the length of LG. So I can say that JL is 1/2 LG. This is the length of LG. Or we could go the other direction and say that this is 2 times JL. This is JL. And we're just told that one piece is 1/2 of the other. So if I'm looking at these relationships then, well, if this piece is exactly twice this piece, and this piece is exactly twice this piece, right, we can say n/5 is the same thing as if we do LG over 1/2 LG. Okay, those ratios are exactly the same. n/5 is 2. LG over 1/2 LG would also be 2. So the answer to this question would be yes, because these ratios are the same. Okay, so if I get the same ratios, these lines are parallel. We're probably not going to see too many problems like this. Right? The problems from this section are more going to be focused on things like this first example, where we're solving for a missing piece. Okay? But just understand that we can use this statement in reverse. Say, if we do have equal ratios here, then that means these lines are parallel. Right? Questions? So that's just part of that one, yeah. So let's take a couple of minutes then and practice a couple of these down below here. Okay, now I do want to point one thing out. On number 5, we're given the entire length of this side. So to use the idea that we've been talking about, we need to just find this piece, okay, to set up the proportion. So I'll leave you with that, see if you can figure that one out. So let's take a minute or two here and see what we can do with some of these here. So like for number 1 here, we just want to match up corresponding pieces on the other side. So the x here would match up with 5 over here. So I can write x over 5 equals, and then I want to do the same thing up here. The 7 would match up with the 5 here. So x over 5 equals 7 over 5.
You always start with the 5, like the x?
Yeah, that's a good place to start. But you don't have to.
Like, I was talking, start with the x on this side.
Yeah, so since we started with x here on this side, we would have to start with the 7 on this side to write our second one.
Alright. So is that just, that's it?
Well, then we would, to solve, we would cross multiply. So 5 times x, and then 5 times 7. And then to solve for x, divide both sides by 5.
So you would have to.
We would get x equals 7.
How did you 3?
So this one is a little trickier because we can't really set up a proportion. But what we can say is this side would be exactly half of this side. These pieces are equal. So what that ends up meaning is this side is just going to be exactly half of this side.
Next you're gonna tell me.
So yeah, this one's a little different because we don't have any measurements over here at all. But yeah,
Hey, did you get this for two? Start out like this.
For the first one, I got.
so since you wrote your first fraction as x over 5, since you started on this side, you would have to write your second one starting on this side, right? As 7 over 5.
Oh.
So yeah, this one's a little. I'm not giving any measurements, but if these two pieces are equal,
That was we've got crackers. Oh my God.
How'd you do number 3?
Versus these two.
I hear it. This cheese tastes like salami. Nope. 5 over X. 5 over X.
Hey, Fach.
So
for this one, you just take 35 divided by 2.
Yep.
You get all smarter than that. Three.
You should not start yet.
So on this one, even though we're not given measurements, if these two pieces are equal, this would just be half of this. Same thing over here. We can say this is just half of this. Therefore, this
Did you get the 5?
half of this.
If I think you're on this.
So on number 5,
So is it x over 11?
this
And then x
thing
over
is
1.
and this piece is left. This one. Well, if the whole thing's 33, we know this piece is left.
Yeah, I know. Just subtract them.
We're just subtract. So we would have 2 left over.
What do I do with the x plus 12?
So then it looks the same as the last piece. So we can set up a proportion. So this one, we kind of just have to think about a little more in this way. So
So what you just said.
these 2 pieces are the same. This. This.
There's 2. 20x
I'm not.
equals
I'm not about, but you won't be able to see them this.
Yeah, you should track the smallest x per straight.
Yeah.
So it's minus 11x minus 11x here.
Yeah. Yep. Subtract the left side there.
So it would be 9x equals 132.
Oh, wait a minute. This would be 22, right? So if we do 33 minus 11, that would be 22 for that piece.
Oh, I wrote 20, my bad.
Yeah. Perfect.
Do not start yet. Do not
So-
start yet.
This one we have to think about a little bit more. So
I wrote it again.
is equal to this. That means this is just half of
So you got 132.
Same thing over
Yeah, I
here.
think so.
This is just half of that entire.
I don't think so, not this one.
So it's probably the same thing with this.
That's correct.
That's correct.
That's all I got.
So you got
What's 132 divided by 11?
12.
I already did that, but I wasn't sure if that was right.
Yes, that is correct.
These look correct.
Perfect. Oh my god. Must be butter. You heard that one? You heard that one?
Hey, don't start. Hey, are you starting? Are you starting?
Not yet. Must
So,
be butter.
fat.
I got it.
So this one would do x over 10 and then x plus 10 over 30.
Yep.
Screw that, it's not working. Hey, what?
Is this a different thing?
No, not really. It's pretty much the same thing. Well, just think about like if this were a triangle, it's the same thing. We're just gonna match up the corresponding pieces. So x over x plus 4 equals 3 over 5.
Fat, I need help.
Oh, but there's like a.
Just like this one? Or?
Yeah. Yep. You'll distribute the 10 to both of those things.
So it'd be 10 and then write that equation.
Yeah. Yeah. So
So
10
10 and then
times
x
x
plus
plus 10. Yep.
I read geometry class.
We mix a lot of algebra stuff in. Geometry and algebra are actually entirely based on one another.
No, it's geometry.
So x squared, right? That's something you talked about in algebra. What that literally means is find me the area of a square with sides inclined angles. So that's algebra and geometry.
That's probably why you take algebra first and geometry. Wouldn't it be better to go from algebra 1 to algebra 2?
I think there are some states that do that. Ohio, algebra 1, then geometry, then algebra 2. Because most of the stuff that the algebra stuff that we do in here only requires algebra 1. We don't do any of the more complicated algebra 2 stuff in here.
There's geometry too.
Not in high school. Alright, it seems like these fit pretty well. Okay, so take a look up here at the answers. Okay.
Yeah.
Are there any that we want to take a closer look at? Number 5. So let's start with 5 then. So on this one, the only tricky thing about setting this up was we were given this entire length of 33. So to use the setup that we've been talking about, we need to find this piece of this side. Well, to do that, I would just take 33 minus 11 and get that this piece is 22. So then, to set up a proportion, I can match up corresponding pieces. So we can say x plus 12 over 22 equals x over 11. Then cross multiply, so we'll have 22x equals 11 times x plus 12. Distribute the 11 through. We'll get 11x plus 132. Subtract the 11x over. And we'll be left with 11x equals 132. Divide by 11, and we'll get x equals 12. Any other questions on these? That's what we just did. Okay. Any other ones? All right, then go ahead and flip over to the back. Okay, the back is pretty similar, except we don't have triangles, we just have lines. So let's just go ahead and jump into an example here. Okay. On, oh wait a minute. No, we're not going to do number 1. Let's jump down to number 4 actually. Okay, let's take a look at number 4. On this one, okay, we're going to use the exact same idea that we did on the front. Okay, it looks a little bit different, but if I know these lines are parallel, we're going to use the same idea. Okay, if these lines are parallel, they're going to cut these transversals proportionally. So what that means is I can just match up corresponding pieces and write in proportion. So we can say y plus 2 over 8 equals y over 5. Okay, we're just matching up corresponding pieces and then cross multiplying. Okay. It doesn't matter. We could have started here and done y over 5 plus 2 over 8. Either way. So now, when we cross multiply, we have 8y equals 5 times y plus 2. Distribute that 5 through. We have 8y equal plus 10. Subtract 5y over. Get 3y equals 10. Divide both sides by 3. And in this case, yeah, we get 3.333333333. Yeah, we could do that. We could just write it as y equals 3.3 repeating like that. Or you could fill up your old paper with reads, but then you still have to put a repeating sign for the last one. Alright. Questions on something like that? Alright, then you guys try 5 and 6. Okay, try 5 and 6.
Yeah.
don't think those ones are.
This is real.
So,
I can't really do much this weekend then. I have to get a heart monitor. I have to wear it for a week. So the hospital can track my heart rate for 2 days straight. Huh? I can't smoke weed. That's to make me sober all weekend. Like when I smoke, dude, my heart rate was like 195, 200 and shit. And that's like full on track star running. I'm just sitting there like, stare at the wall. I've said that before.
Yeah. We're gonna
Especially when I
be
was
together here in a second.
Oh, dude. I didn't even know how to get to my dad.
Yeah, this one does end up being tricky because when we cross multiply, we'll end up getting
She brought food, buffalo wild wings. She brought a whole bunch of wings, potatoes.
there's a different way to do it.
Well,
Yeah,
anyways, over there, like, alright.
we're not gonna look at it.
Sure. Anyways, it happened. And then, like, 20 minutes goes by, I come back to my room. My wife comes here, my TV like, I try to talk to her, she's like, well, dude, that's just, oh my god. That's the only thing I'm fucking
Chips.
Daddy, what did you get for the?
You did show you my whole, I have a whole, so many times.
Sit down. Really? 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 I'm gonna eat trash. Jacob. Jacob. You're a bitch. You're a bitch. Huh? You're a bitch.
No one's.
I love you. You love Jacob, dude? What? It was fun at first.
You're a meeting thing.
I started laughing so hard.
Because I pointed out your inspiration.
Alright, I think for number 5,
What are you doing? Don't do that.
I think for number 5, we've gotten 12, and for number 6, 3. Right? Questions?
Yeah.
16.
Yes, but we have to do something before we do that.
Yeah.
So, I want to do one more before we get out of here. We're going to take a look at number 3. Right? If we look at number 3, we've got X's and Y's all over the place. Right? what I need to do first to solve a problem like this is notice that I'm told that these two segments are equal to each other. So what I can do before I set up a proportion is set these equal to each other and solve for x. Okay, so on this one, the first thing I'm going to do is say 2x plus 4 equals 3x minus 1. Okay, now we cannot always do that. This is just a special case because I'm told that those two things are the same. Okay, I'm told by these markings that these are the same. So I can solve for x here. Subtract 2x over, add the 1 over, and we get that x is 5. Okay, so now remember, this isn't always the case. This is just a special case because we're told these are equal. So now, what I can do is take that 5 and plug it back in for x. So if I plug 5 in here, 2 times 5 plus 4 would get me 10 plus 4, so 14. I would get the same thing here, right? 3 times 5 would be 15 minus 1 is 14. So now we could set up a proportion. Okay? Now we can set up a proportion and cross multiply. So we could say 2y plus 2 over 14 equals 3y over 14. Cross multiply. 14 times 2y plus 2 equals 14 times 3y would be 42y. Distribute the 14 through. Get 28y plus 28 equals 42y. Subtract 28y over. Get 28 equals 14y. Divide by 14 and we should get y is 2.